Hello, 7th graders. It's good to be back from leave and be able to teach you for the last couple of weeks of school. As you recall, I had a baby in March named Rosie. And if you're wondering what the last 11 weeks have been like for me, well, like you, I've been quarantined with my family, and I've had to try and come up with ways to keep my kids busy. I also learned a lot of new skills.
What happened?
What do you mean? Like toothpaste removes dry erase marker from wood. Anyways, I am so very proud to hear of all the progress that you made while I was away on learning about the earth science through remote learning. And on Thursday this week, Mr. Bingaman and I will ask you to do an informal assessment that's not quite an exam. It is open resource, and we recommend that you answer whatever you cannot find using your labs, your videos, or any websites that you may like. And I want to reiterate to you that this is not for a grade. It's just a way for you to reflect on what you learned in the past unit. We would like you to redo the assessment until you have the best possible score that you are able to get using your resources. Let's review how do storms happen. If you recall from the energy unit, light energy comes from the sun. This light passes through the transparent air particles and cannot be absorbed. Once the light hits the ground, it gets absorbed and gets converted into thermal energy. The thermal energy in the ground gets transferred to the air particles above. This process is called conduction. The darker surface absorbs more light energy, therefore it has more thermal energy, and is relatively warmer to a lighter colored soil or surface because it reflects more of the light energy and less of it gets converted into thermal energy. As a result, you have a warm air mass and a cold air mass. The warm air mass is less dense than the cold air mass because the particles are moving faster and therefore spread out more, versus a cold air mass is more dense because the particles are more closely compacted and moving slower. Because the warm air mass is less dense, it is going to rise, versus the cold air mass is more dense and therefore it is going to sink. This rising warm air is called an updraft, and sinking cold air is called a downdraft. When this warm, moist air rises up, it leaves a void behind that we can't have. So air on the surface from the downdraft fills in under the warm, moist air. This movement of air is called surface winds. When the cold, dry air sinks in the downdraft, this makes room for the warm, moist air of the updraft to rush over in its place. This movement of air is called upper winds. This process of cycling the surface winds, updraft, and upper winds and downdraft is a process known as convection. The cold, dry air sinking in the downdraft creates an area of high pressure. Think about it as if you were on the ground. The downdraft will be pushing on you and you would feel that pressure. Versus the warm, moist air is moving up in an updraft. So think about it as air is being lifted off of you, and therefore this is an area of low pressure. As warm, moist air goes up in altitude, it also loses more pressure. Connect this to the lab where you took a phone and placed it on the ground on a chair and up high. As warm, moist air goes up, there's less air pushing down on it. Therefore, there is less pressure. Warm, moist air that has low air pressure is unstable, and it can no longer hold the water vapor in a gaseous state. As a result, water droplets condense and form clouds. The upper winds stretch out the cloud across the fronts. Remember, fronts are the boundaries between warm and cold air masses. When this warm, moist air gets stretched out across cold, dry air, it causes even more of the water vapor to condense in the cloud. The droplets can no longer stay in the cloud because they are too heavy, and it falls down as rain. And that is a basic model about how rain happens. Now obviously weather is a lot more complex than this, but it still operates on that same idea of warm and cold air masses intermingling with each other in the atmosphere. Combine this with different types of winds, and the temperatures, and the amount of moisture in the air masses, and we get a variety of different types of weather. The green zone, or extension for this week, is a great way that we would like you to close out the end of the school year. We would like to present you with our last build challenge, which is to construct and fly a kite. There are 4 models of kites that you can preview under the June 2nd part of the checklist, and we have instructional videos and examples of different types of kites that you can make. Many of the kites use butcher paper from school, but to supplement, you can instead use wrapping paper. It's a really good substitution for the butcher paper. Invite your family to build a kite with you, or several kites, and kind of come up with a theme together. And if you do end up building kites together, we would love for you to send us pictures or video of you making or flying your kites, and we would love to put it up on our social media if you're okay with it. We wish you and your family a safe and happy summer, and don't forget to visit us next year when you're 8th graders. Take care and be safe.